Ms. Rivera, I've got a geometry problem that's making me think really hard. It says, in polygon ABCD, the measure of angle A is 49 degrees, the measure of angle B is 107 degrees, and the measure of angle C equals 2 times the measure of angle D. I need to find what the measure of angle C is. I'm just not sure where to start with all the angles combined in a polygon like this.
I can see why this one's making you think, Cody. It packs a few different pieces of information together, and the trick is remembering a fundamental property of any polygon like ABCD. Since it's a four-sided polygon, what do we call a shape with four sides? And more importantly, what's the sum of its interior angles?
Oh, right. A four-sided shape is a quadrilateral. For the sum of its interior angles, I'm thinking it's 540 degrees. I always get the general polygon formula a little mixed up.
You're absolutely right, Cody. It is a quadrilateral. That's a great start. For the sum of the interior angles, 540 degrees is actually for a different polygon. Do you remember the general formula we use to find the sum of the interior angles for any polygon? Or perhaps how many triangles you can divide a quadrilateral into?
I think I remember something about dividing it into triangles from one vertex. So for a quadrilateral, you can make 3 triangles out of it, right? If that's the case, then wouldn't it be 3 times 180 degrees?
You're thinking along the right lines with dividing it into triangles from one vertex, Cody. That's exactly the method. But let's just double-check how many non-overlapping triangles you can form inside a quadrilateral from a single vertex. Try drawing a simple four-sided shape and connecting one vertex to all the other non-adjacent vertices. How many triangles do you end up with?
Oh, I see. If I draw it out, picking one vertex in a quadrilateral, I can actually only draw one diagonal to a non-adjacent vertex. That means it forms 2 triangles, not 3. So, if it's 2 triangles, then it should be 2 times 180 degrees, which is 360 degrees. Is that the sum for a quadrilateral, Ms. Rivera?
Excellent, Cody. You've got it exactly right. A quadrilateral can indeed be divided into 2 triangles from one vertex, and since each triangle's angles sum to 180 degrees, the sum for a quadrilateral is 2 times 180 degrees equals 360 degrees. That's a crucial piece of information for this problem.
Okay, 360 degrees makes so much more sense now that I visualize the triangles. So, we know the sum, and we have the measure of angle A and the measure of angle B. How do we put the measure of angle C and the measure of angle D, where C is 2 times D, into the equation?
That's exactly right, Cody. Visualizing those triangles really helps solidify that concept. Now you have the total sum of all the angles, and you have expressions for each individual angle. How would you write an equation that includes all 4 angles and sets them equal to their total sum?
Okay, so it would be the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equals 360 degrees. If I substitute, that's 49 plus 107 plus 2 times the measure of angle D plus the measure of angle D equals 360. So it comes out to 146 plus 3 times the measure of angle D equals 360 degrees.
That's an excellent setup, Cody. You've correctly combined all the known angles and the relationship between the measure of angle C and the measure of angle D into a single equation, and you've simplified it perfectly to 146 plus 3 times the measure of angle D equals 360 degrees. Now that you have that equation, what's your next step to solve for the measure of angle D?
Okay, so I need to isolate 3 times the measure of angle D. I'll subtract 146 from both sides. So 360 minus 146, I think that's 224. So 3 times the measure of angle D equals 224 degrees.
You're doing great, Cody. Subtracting 146 from both sides gives you 3 times the measure of angle D equals 214 degrees. Now that you've isolated 3 times the measure of angle D, what's the final step to find the measure of angle D?
Okay, so I need to divide 214 by 3 to get the measure of angle D. Let me see. 214 divided by 3 is about 71. Is the measure of angle D 71 degrees, Ms. Rivera?
You've correctly identified that you need to divide by 3 to find the measure of angle D, Cody. However, I think we might have a small arithmetic error from a step or two back. Let's revisit the sum of the measure of angle A and the measure of angle B. Can you quickly re-add 49 degrees and 107 degrees for me?
Oh, you're right. My bad. 49 degrees plus 107 degrees is actually 156 degrees. I must have added that wrong before. So it should be 156 plus 3 times the measure of angle D equals 360 degrees.
Yes, that's exactly right, Cody. 49 degrees plus 107 degrees is indeed 156 degrees. It's easy to make a small arithmetic slip. So now our corrected equation is 156 degrees plus 3 times the measure of angle D equals 360 degrees. With this updated equation, what's the next step to find the value of 3 times the measure of angle D?
Okay, so 156 plus 3 times the measure of angle D equals 360 degrees. To find 3 times the measure of angle D, I need to subtract 156 from 360. So, 360 minus 156 is 204 degrees. That means 3 times the measure of angle D equals 204 degrees.
Excellent work, Cody. You've correctly subtracted 156 degrees from 360 degrees to get 204 degrees. Now that you have 3 times the measure of angle D equals 204 degrees, what's the very last step to find the measure of angle D?
Okay, so I need to divide 204 by 3 to get the measure of angle D. If I do that, I get 69 degrees. So, is the measure of angle D 69 degrees?
You're on the right track, Cody, with dividing 204 by 3 to find the measure of angle D. That's the correct operation. Could you just double-check your division there? What do you get when you calculate 204 divided by 3?
Oh, right. Let me try that division again. 204 divided by 3 is actually 68. So the measure of angle D is 68 degrees. Is that finally correct?
Yes, Cody, 204 divided by 3 is indeed 68. You found the measure of angle D to be 68 degrees. Now that you have the measure of angle D, can you use the relationship given in the problem to find the measure of angle C?
Okay, so the measure of angle D is 68 degrees, and the problem says the measure of angle C is 2 times the measure of angle D, so I need to multiply 68 by 2. That would make the measure of angle C 136 degrees, right?
That's absolutely perfect, Cody. If the measure of angle D is 68 degrees and the measure of angle C is 2 times the measure of angle D, then 2 times 68 degrees equals 136 degrees. So the measure of angle C is 136 degrees. Congratulations, you've solved the problem. To summarize, we first remembered that the sum of angles in a quadrilateral is 360 degrees, then set up an equation with the given angles and the relationship between the measure of angle C and the measure of angle D, solved for the measure of angle D, and finally calculated the measure of angle C.
Awesome! Thanks so much, Ms. Rivera. I definitely feel much better about this now. Figuring out that 360-degree sum for quadrilaterals and remembering to check my basic addition made a huge difference.